So this observatory is very important for the Maltese Islands. It provides a venue for researchers, students to have access to an instrument like this, a highly technical instrument, and it gives some freedom for Malta to contribute to astronomy.
So the location that we chose for the observatory was chosen on the basis of studies we had carried out beforehand. These are studies that measure the brightness of the night sky, and of course we needed to find a location that was as dark as possible. And in Gozo, the two prime locations we found were Dwejra, as we were expecting, and Nadur, the site of Tasop in Gozo.
So if I talk about my research, it involves calibrating the observatory and researching the limitations of this observatory, and this will pave the way for future astronomical research. Like that, I'll have the data reduction and the calibration ready.
So the site being a little bit remote compared to other sites, and that's by necessity, of course, but that in itself has some challenges, right, in terms of not having, of course, facilities around you, but the principal issue remains light pollution, in the sense that although we chose a dark site, Malta and Gozo are heavily light polluted, and that means that especially when there are any clouds, they very easily reflect light, artificial light. Of course, we try to choose the best nights on which to image, but you cannot, of course, do away with the problem unless the issue of light pollution is tackled head-on, in the sense that we need to reduce light pollution in general on the islands.
So this observatory provides a place for researchers and students such as myself to actually learn how to use instrumentation and get experience with an actual telescope. So I'm being trained to use it, and other students will also be trained with it.
So the observatory has a half-meter optical tube, so that's the telescope itself. I mean, when people think about a telescope, they generally think about this tube that collects light, right? So that's a half-meter aperture telescope. But then the observatory is also equipped with a specialized scientific camera that can take images. It has very high sensitivity to be able to image very faint and far-away objects. It has also an adaptive optics module that allows us to compensate for certain vibrations and other effects that we might encounter, such as turbulence in the atmosphere and so on. And then we also have an auto-guider that corrects for any errors in the tracking of the telescope itself. And the whole system of equipment is housed inside the dome that moves and aligns itself with the telescope itself. So as the telescope is operated, the dome can follow the telescope wherever it goes, and the entire observatory can be also operated remotely.
So with certain telescopes, such as the Nadur Observatory, we have what are called filter wheels. So these filter wheels, they contain a set of filters which we can rotate through while taking our images. So for example, for these images that we took at the observatory, we took images with the luminance, red, green and blue filters. The luminance filter essentially means you're imaging the white light. And essentially what this does is it allows us to gather as much light from each color as possible, so that later on we can merge them together to create a colorful, scientifically accurate image, which is very important for astrophysics and the studies we do. So after we've reduced the noise from all the images, I will collect the data into separate folders for each filter. Then for each filter, we align them such that all the stars are aligned together so that we get a coherent image, and then we stack the image together. We will merge them together to form a color image. Today I will be forming a color image of the Pleiades open star cluster, which is an open star cluster containing more than 1,000 stars. It comes out looking very blue, and it's a very beautiful star cluster to look at, and it's also visible with the naked eye. So astronomy is, I think, one of the most beautiful sciences. It always looks to answer the question, where do we come from? How did we start? How did we come to be? Where did the universe come from? And there's always something to be learned from astronomy, and no matter how far we look, we'll always find something new. So that's what I like the most about it.
What I love about astronomy is the fact that it opens up a different perspective on our daily life even. You see that many of the problems we face on a daily basis are not really problems in the grand scheme of things, so to speak. It also, I think, makes one stay humble. That's something that's been said many times, and it simply shows me how beautiful the universe that we inhabit is, and beautiful not just aesthetically, but also in terms of its mathematical beauty, in terms of the beauty of the physical laws that govern it. There's beauty everywhere you look.